alkaline earth metals. Group 2 elements are called as alkaline earth metals, and they are beryllium, magnesium, calcium, strontium, barium and radium. Okay, these are the elements present in alkaline earth metals, and they are alkaline in nature and they are existed on earth. So they are called as alkaline earth metals. And beryllium differs from the other elements in the group, and it shows diagonal relationship with aluminium. Okay, next, electronic configuration. Electronic configuration. Electronic configuration is first noble gas configuration and NS2. N is equal to 2 to 7. Okay, first example, beryllium. Nearest noble gas is helium. Helium configuration and 2s2. What about magnesium? Nearest noble gas is neon and 3s2 and so on. Next, second characteristic is atomic radii and ionic radii. So from left to right, the size decreases. Okay, so compared to alkali metals, these are having smaller size. So atomic radii and ionic radii are smaller than corresponding alkali metals. Okay, and they have higher nuclear charge because electrons are more attached towards the nucleus. Nuclear charge. Then down the group, the atomic radii and ionic radii increases. Down because the size increases down the group. Okay. Next, third characteristic, ionization enthalpy. Ionization enthalpy. Ionization enthalpy is low. Low ionization enthalpy because of large size. Okay, but down the group, ionization enthalpy decreases. Down because the size increases, number of shells are increasing down the group, so ionization energy decreases down the group. Next, first ionization enthalpy and second ionization enthalpy. Case of first ionization enthalpy, what happens? The energy required to release the outermost electron, which is greater than or higher than corresponding alkali metals. Okay, because of smaller size. But after the removal of one electron, to remove the second electron, it is easier. So second ionization energy is smaller than corresponding alkali metals. Okay. Now, next property, hydration enthalpy. Fourth property, hydration enthalpy. Hydration enthalpy. Hydration enthalpy is higher than those of corresponding alkali metals because they are having smaller size. Okay. So hydration enthalpy is larger than corresponding alkali metals. Okay. So they are more extensively hydrated. So for example, in the case of MgCl2 and CaCl2, they are hexahydrated, that is MgCl2 6H2O and CaCl2 6H2O. But corresponding alkali metals NaCl and KCl are not hydrated. So hydration enthalpy is larger than corresponding alkali metals. Next, hydration enthalpy decreases down the group. Okay, the order will be because size of the ion increases. Okay, so hydration enthalpy decreases down the group. Next, magnesium, calcium, strontium, barium. So hydration enthalpy decreases. This is the order. So it decreases down the group. Next, physical properties of alkaline earth metals. Physical properties. They are silvery white, lustrous, then soft and harder than alkali metals. They are lustrous, then silvery white, but harder than alkali metals. Also, beryllium and magnesium are greyish color. Okay. Now their melting point and boiling point. What about their melting point? Melting point and boiling point are higher than alkali metals because of their smaller size. Okay. Melting point and boiling point are higher than alkali metals. Then next point, they are strongly electropositive. Okay, because of their low ionization energy. Okay, low ionization energy, so they are highly electropositive. Then electropositive character increases down the group because the size increases, ionization energy decreases, so down the group electropositive character increases. Okay, next, flame color. It gives flame coloration, that is calcium, strontium and barium gives flame test, and the colors obtained are brick red for calcium, then crimson color for strontium and apple green for barium. So this flame test, okay, this is helpful in the detection in the qualitative analysis and estimation of flame photography. Flame photometry. So this is used for the detection of these elements by using flame photometry, and in flame what happens, electrons are excited to the higher level, and they were when they return back to their ground state, energy is emitted and visible energy is emitted in the visible region. So we will get different colors for these compounds. But in the case of beryllium and magnesium, they are smaller size, so electrons are strongly attached, so and they are not excited and they do not impart color, do not impart any color to the flame. Okay, and also these are metals, so they have high electrical and thermal conductivity, high electrical and thermal conductivity. These are the important physical properties of alkaline earth metals.